Hello YouTube. Thought I'd do a quick video here. I did upload this video, but I made an error in it, and I had to redo it. It bothered me. So that's why, if you happen to see it was a video and now it's gone, that's why I deleted it. I want to do it better. And I had an error. Well, it wasn't a big error, but to me it was. So I'm reshooting the video. Anyway, I was talking with somebody on my Zello channel the other day, and we were talking about GMRS two-way radio wattage amplifiers. Plug and play type that you just buy, you hook the cables up and away you go, or the DIY kits that you have to solder together. I'm going to talk about both of them in this video. I'm going to tell you what to look out for. I'm going to tell you what parts you're going to need with the DIY kits that are not included. I'm going to talk about, like I said, information on the plug and play type. So I'm going to, just hopefully it won't be too long of a video, but I'm going to tell you all the information that you got to watch out for and that you need to know. Okay? So a couple things here I want to point out right off the bat before I forget. Now, the wattage. How many watts should you get? Now, obviously, the FCC says for GMRS, we can only run 50 watts. That's 50 watts going to the antenna. Okay? So, with that being said, keep in mind, if you're going to use your amplifier with a duplexer, then you might want to consider getting a little higher wattage amplifier because by the time it goes through the duplexer, you're going to lose power. And if you get a higher wattage amplifier, that will help make up for it. Okay? Now, if you're not going to use a duplexer, then you don't have to worry about getting a higher wattage amplifier. Okay? So in this case, I would use it with a duplexer. So I need a little higher wattage amplifier. That's why I typed in the eBay. I'm using eBay for an example here. That's why I typed in UHF amplifier 100 watt. Okay? That's why I typed that in. Now, another thing you want to consider, there's a couple things you got to be mindful of. Whether it's a plug and play amplifier, whether it's a DIY kit that you solder together amplifier. You got to make sure the frequency is going to be what you need. You got to make sure it's going to be the right voltage you're going to need, and how much current and how much amperage does it take to run that amplifier, and how many watts input do you need to achieve the wattage output. And I'll explain more of this as we go. So let's start with the DIY one first. We're going to pick this one here for an example. The first thing I notice, okay, it's within the GMRS frequency range. That's good. That's a plus. Not bad price, $46.87. Not bad. From China. It's going to take a while to get it. Let's dig into this a little bit more. Let's see what do we get with this. Now, this one here is a kit. You have to solder it together. And there's components that are missing. So I'm going to tell you this right now. Most of the kits out there will not come with all the parts you're going to need to make this amplifier work properly. And I'm going to show you what I mean here. So let's look at this kit. Let's go to the kit. This is what you get when you order it. This is what you get. Now, a lot of these kits are going to use surface mount technology, which means you're going to be soldering little small components. So if you have never done that before, then you probably don't want to get a kit, because most of these kits are going to have really small components. And I'm going to show you what I mean here. If you look right here, those are surface mount components. Okay? They're really small. Let's get red. I like red better. Okay. They're really small. There's a package of them here too. So that's one thing about this kit that I noticed. The second thing I noticed about this kit, it does not come with a heatsink. I noticed that. And I'll explain what that is. A heat sink is what it's exactly what the name says it is. It transfers heat off a component so that component does not overheat. Technically, you probably want a heat sink and a fan ain't a bad idea. But nevertheless, this does not come with a fan. It does not come with a heat sink. Actually, you want a heat sink and a fan, both. Now, let's talk about the heat sink. This output transistor IC is what does the wattage. Okay? This gets mounted in here. Now, you can see there's holes here. These holes here are usually for a heat sink. And a heat sink, like I said, is going to be a block of an aluminum. It usually has fins on it, but it's a aluminum chunk of a block. And that gets mounted. You put thermal paste on the IC transistor, and then the aluminum block sits on top of that after you soldered it all in there. And then the heat from coming off this component gets drawn in by the aluminum block that prevents that component from overheating. Okay? So you're going to need a heat sink. The other thing I see that it's also missing is they give you the wires right here. This blue wire and this kind of a clear wire. I'm going to assume that this wire here is probably going to be the RF in, and this blue wire would go to the RF out. If you see the circuit board here, RF in, and the blue wire is usually the output. But there's no connectors on those wires, so you got to supply connectors. Okay? Second thing that I see, there's no wire for the power. You got to supply your own fuse and your own wire. Not a big deal, but you don't want to hook this up without a fuse, inline fuse. Okay, there's no wire for that. Another thing that I see, the coils, you're gonna have to hand wind the coils, and the coils right here, it's this bare wire right here. You're gonna have to hand turn those. And what I mean by that is, let's go to another picture here. Let's go to the picture they show it already built. Okay? And this picture is not really even complete because they didn't solder in the transistor, which would go right here. That transistor I was talking about, it's not soldered in right here. So, but the coils I'm talking about are right here. These. Now, hopefully the directions will tell you. That's another thing. How good are the other directions? You need to know what diameter this coil has got to be wound at, and you need to know how many turns, which obviously looks like 2 turns here. And the diameter of the wire, well, we already know that because the diameter of the wire, because they're supplying the wire. Now, what's interesting too, I see some coils here. Well, those are different diameter wires, so don't look to be the same wire. And these wires, they're showing white. That's not really what's, I guess, the kit here doesn't really show that as white wires. They show it as a bare wire. So I'm going to assume this bare wire is the white wire that you saw in this picture here. That's probably the bare wire here because it looks the diameter looks to be about the same. But where these smaller coils here, I don't see that in the parts list. So do you? Maybe they just don't show it. I'm not sure. So that's another problem, or it could be a problem. Hopefully it tells you in the directions, you know, what wire to use. Another thing too, if you look at this is the pre-built one, obviously. If you look at right here, there is a trimmer resistor. And I'll bet you that resistor probably does the voltage biasing for that transistor that gets soldered onto here. The part that needs the heatsink. I'll bet you're going to have to adjust the bias voltages on that, which is not a big deal if you know if you got a voltmeter and you be real careful so that you don't burn up the transistor. But these kits do not come. Obviously, it's a kit. You have to tune it. So you got to do all the tuning So that's kind of the downside about these kits. Again, there's no enclosure box, there's no switches, there's no fuse for the inline fuse, there's no heat sink. Probably should have a fan. That's 100 watts. You probably want a fan on top of the heat sink to help cool it. They don't come with none of that. You just get the circuit board and parts, and that's all you get. So keep that in mind when you're thinking about a kit. Let's erase that. Okay. So let's look at this kit a little bit more. Let's scroll down. So that's one thing. Those are some things you got to be mindful of the kit. Like I said, the frequency does fit our frequency range, so that's good news. So let's kind of scroll down. Well, it's in China. It's going to take a month to get it. $3 shipping, not bad. Not bad. Let's scroll down here, look at the specs. Oh boy. That's what I was kind of worried about. Okay, well, we got problems. The first problem we got, the voltage, right here. 24 volts. Well, then, I mean, if you want to put this in your car, obviously that's not going to work. You need a 12 volts. So that ain't going to work if you want to put this in your car. If you got a variable power supply in your bench, I suppose, if you can go up to, if your variable power supply, you can adjust it to 24 volts, then you're good to go. But this would not work in your car. So that's one thing I don't like. The other thing I don't like is the input wattage. Remember I was telling you in the beginning of the video, the amplifier, whether it's DIY or plug and play, there's going to be input wattage requirements. How many watts do you need going into the amplifier to get what you want going out? Okay? So, the problem we have here, 8 to 10 watts. Okay, well, that ain't going to work with a handheld. So, this amplifier will not work with a handheld. Even if the voltage was 24 volts, I could not use a handheld on this. I would have to use either a repeater or a mobile, and hopefully the mobile does not do more than 10 watts. So to get my 100 watts, I need 10 watts going into it. That's what I'm trying to tell you. 100 watts, I need 10 watts going into it. Okay? So this amplifier would not work for me. The voltage is wrong. And then you got to watch out, the current, 7 to 8 amps, not a big deal. In this particular case, you could use a 10 amp fuse to protect the amp, the inline power fuse I'm talking about. But this would not work for me. I don't want 24 volts. I don't want to do that. And this guy does not, at least, okay, good news, he does tell you up front the heat sink's not included. And you need to solder it, because a lot of people don't understand that. So right here, this guy does tell you exactly what I just told you. Heat sink not included. So, and then like I said, you need the connectors, the power, the fuse, all that. So this one would not work. So let's go do some more checking here. Let's go back. Let's scroll down. Okay, here's one. Oh, nope. 420 to 460. Nope, that ain't going to work for the GMRS. I need to go from 462 to 467. This would not work. So let's go a little bit more. Scroll down. Okay, here's one. 400 to 470. 80 watt. Oh, it does do 12 to 14 volt. Let's look at this one. This one's plug and play. You don't have to build it. It's got fans. Oh, that's looking good. Let's get a little closer up here. It's got fans. That's a plus. Oh, missing one part. Not a big deal. There's no fuse. You need to put a fuse on that for the power feed. Not a big deal. Like I said, you can buy a cheap inline fuse, so you got to do that. Does this one have high and low? Let's look at the pictures. Nope. There's just a rubber cap. This is the input, because this is the SMA you would use for the input. to feed the amplifier, whether it's coming off your handheld radio or whatever the case may be. Output is going to be the PL259. Okay, not a big deal. This is the heatsink. This is exactly what I'm talking about, a heatsink. Kind of hard to see. Let's erase this. This aluminum piece right here is the heatsink. See how it has fins? And then to make this better, they put a fan on it to help blow the air will blow out of these out of these. The hot air will blow out of the fins. So that's what a heatsink is. This aluminum block right here. This one happens to be black. They come in silver. Usually they're silver, but this one's black. So it does have a pretty good heatsink. So that's a plus, and it does have 2 fans. So that's also a good thing. No high and low switch, not a big deal. We can adjust that by the feeding the. We can adjust the wattage going into it. So we can adjust that by adjusting our radio. If it's a handheld, you got low, sometimes low, medium, high. So we can adjust it that way. So, and like I said, no fuse, not a big deal. We can add a fuse. So, okay. It's got an LED. It tells you when it's on. So let's look at the specs a little bit more. Let's see what else this one does. $148, not bad. 80 watt, 12 to 14 volts. This will work. $6 shipping in China. Probably take a month to get it. 80 watt. Maximum output power. I don't know if they say it can go up to 100 watts. That's what I'm taking it as. But it's only rated for 80 watts. So, and then I'd like to check what they got written here along with the title to make sure everything matches. 80 to 90 watts. Okay. All right. 400 to 470. That's within the GMRS frequency. Transmitting, okay. Power usage, 80 watt. Uses 13.8. 30 amp, good linear. Okay, they're saying they're recommending a 30 amp power supply if you're going to use this in your house. Can output 90 to 100 watt. Okay, input power 2 to 7. That's not bad. That's not bad. So handheld would power this, but again, I'm gonna say this again. To get the let me rephrase that. To get the 80 watts output, I'll probably gotta have about almost 7 watts getting fed into it to get my 80 watts. So that's anytime it doesn't matter if it's DIY or plug and play. Anytime they say what the input power is, and if they say 2 to 7 or 2 to 10 or whatever the case is, the higher number, let's pick for an example, 2 to 10. The higher the number, the 10 means that's how much input wattage you're going to need to get the maximum wattage output of that amplifier that it's rated at. Again, in this case, 7 watts. So I'm going to need 7 watts going in to get my 80 watts coming out. Okay? So other than that, not bad. I could use this, my Redivis repeater, before the duplexer does about 6 watts. So it's not quite 7, but I could get close to maybe 60. I'm going to guess if I say 6 watts in, I probably get between 60 to 70 watts out. By the time I feed it through the duplexer, I'm going to lose some wattage, so I'll get hopefully pretty close to 50 watts out. That's why I'm kind of picking a higher wattage amplifier in my case. So this doesn't look too bad. Now what I would do if I was seriously consider this, I would copy and paste this and go to YouTube and try to find some YouTube videos about it. I would go on Google, try to find some reviews of this to see how well it works. So I would do more research. So let's kind of look through. Okay, what this one here, this is 400. Nope, it only does 420 to 460. Nope, that's only 2 watts. We don't want that one. More kits. 100 watts. Probably the same kit we saw just a little bit ago. Let's scroll through and see if we can find some more. Here's one for 159. That might have been a little bit cheaper than the one up here. Yeah, nope, actually that's more. 148. I'm just kind of looking for other different types here. There's the Redovis one. That's one that I have. That's $100. But you gotta make sure, like I say, you gotta check the voltage, the frequency they can do to make sure it does do the frequency you want. Okay, what is this one? That's only 50 watt, $200. You might as well, get the other one for 80 watt. That's only 25 watt. I'm trying to see if I can find a like 80 watt. Now, of course, you can look on Amazon. You can look at AliExpress is another one. This one's 210. This one's actually more. The other 80 watt was cheaper. That's only 3 watt. What is this one? No, this one can do both frequencies. What's the wattage? 2 to 5 watts in. This does both. So this would work. Let's look at this one quick. What's the wattage here? Let's just kind of scroll through this here quick and see. Looks like 60 watt. Looks like for the UHF it's 60 watt. So 2 to 5 watts, that's actually better in the sense of you're going to get closer to your 60 watt output because it's 5 watts. If you have 5 watts, you should get about 60 watts output. So that's a little bit better. This one, current can be between 4 to 12 amps. 12 so yeah, cannot be over 14 volts. So this would work with your car, your 12 volt system in your car. So, that one ain't too bad. Kind of pricey though. $300. That's way too much. But you kind of get the idea. What you got to look for is what I'm trying to show you here. Another here's another one at 50 watt. No, wait, nope. This one does do the right frequency. This one's actually cheaper. This is $89, 50 watt. So that's not bad. I'm just kind of scrolling through here, but you kind of get the idea. Like I said, you have to check. How many watts you think you're going to need if you're going to go through a duplexer, how much input wattage is required to get that wattage, what voltage it runs at, how much current you're going to need to supply it if you got a good enough power supply, if you're going to use it in your house, how much amperage it needs. So whether it's a DIY or plug and play, and the frequency, of course. Make sure you got the right frequency. So those are the things you got to watch for. So hopefully this video kind of give you some ideas. Like I said, the DIY kits are cheap, but there's a lot more to it. Other parts you're going to need. That's the kind of downside of it. Plug and play, you don't have to, you just, exactly what it says. You plug and play. You plug it in and you go. DIY, you got to get more parts. You got to tune it. So that can be a little more, a little more involved if you're not really have done that type of stuff before. So at any rate, I hope this video has helped. If you have any questions or comments, please post them down below. And please subscribe. Thank you and have a good day.